And welcome to another session of Functional Open Science Skills for AI and ML Applications. Once again, I am Michele Cosi, your instructor for this workshop series, FOSS AI. For this series, we go from what open science is, what AI's role in open science is, and slowly walk our way through where we can build our own AI and ML pipeline. And today we are going to be discussing where to get your compute. Going to make a new share. Okay, this is our wiki screen where we can find all of our information for this specific series. And if you were to scroll down, you can see that we are in week 3, and we're going to look at how to work in the cloud and go back and talk a little bit about reproducibility itself as a reminder from what you may have missed from week 1. I have not linked this over here, but you can find this page that we're going to go to today over here, learning to work in the cloud. And I'm going to copy this and paste it into the chat. What we are going to be using this page for today, it's mainly for references. Very similar to what we did last week, simply because it will be easier for me to show how things happen as we go along. It is likely that many of you have not heard of JetStream2, but I can assure you this is something that will become extremely important for your own research, as well as developing your own tools as you go on. And let's look at the schedule for today a little bit. We have a discussion and introduction to the topic between now and the next 5 minutes. And then we're going to talk a little bit about getting off your own machine. And the last big chunk of time, we're going to look at JetStream2. In today's notes, I have added some information about some local resources, such as the HPC, the high performance platform, computing platform that we have here on campus. And I just thought that it would be useful for you to have this information, as well as perhaps a future time that you want to use the what we have here on campus. For today's lesson, it is important for you to understand a little bit of command line, because yes, whilst we have these machines for you to use, or these machines for you to play with elsewhere outside of your computer, we do connect with these machines through something called secure shell, but I'm going to go into that with in a little bit of time. The expected outcomes from today is a quick revisit to what getting off your machine means and reproducibility of your own tools, and knowing where to get compute for your own research. Okay, I'm going to scroll down here a little bit. Getting off your machine in the terms of open science tackles a big point, and that is the big point of reproducibility. You have definitely been in a moment in time where, well, you were asked to replicate someone's code, or you were asked to work on another computer that you may have never used. And this could be a Windows computer, this could be a Mac computer, or an Ubuntu computer. And unless you know what you're doing, sometimes it will lead to issues with your work or what you're trying to do in not your computer. So as I mentioned in week 1, there are a couple of tools that we can use to essentially make this a little bit easier on your side for yourself, but as well for other collaborators. And this is using a software environment such as Conda or a software manager such as Conda and using containers. Because we have already mentioned about these topics, I'm not going to go into them extensively. However, I'm just going to be doing a small refresher. The first is the use of software environments and Conda. And Conda is an environment manager. And what does that mean? I think the best way for me to actually show you would be to take a step back and see if I can show you what Conda is. So let me stop my share here. I'm going to share my terminal for just a second. Okay, so my terminal might look a little bit different than your terminal, but if you have been close to computer sciences, they all kind of look the same. They all kind of function the same, whether you are on a Windows machine or whether you are on a Mac or an Ubuntu machine. So, but I wanted to do a couple of things. First of all, I want to show you that I am at home. So if I do pwd, I show you that I am at home. Some of you might have / your name and then / something like this as a prompt on the left side. However, I wanted to bring your attention to right over here where it says base. Now, base in this specific case means that I am in an environment called base. And within this environment, I have installed a number of software for this. Now, if I were to, because I have Conda installed, I can switch out my environment on the environment list. And please do ignore my warnings. But as you can see, I have a number of environments that I have worked with throughout my use of this computer. What does this all mean? Well, first of all, my base environment has let's call it a set A of tools, which is different than an environment, for example, in this specific case, PyTest, which has a different set of tools installed. How can I look at the list of tools that I have installed in base? I can do so by doing conda list. And this will create a small list of all of the tools that I have installed in this environment. Let's take a look at perhaps what version of Python I have over here. Python, where are you? I have version of Python 3.9.16. Cool, fantastic. As we have seen earlier, conda env list. I have, I was gonna use PyTest as a test, but I'm gonna go ahead and use dplypy4, dplypy being a dendrochronology tool, and it requires its own environment. So I'm gonna go ahead and do conda activate dplypy4. Now you can see my prompt change from base to dplypy4, and I want to go and see what version of Python I have installed. Earlier I had version 3.9 installed, so let's see what I have now. You can do that too. Okay, let's try that. Actually, I don't think Python -- version works, but let's try it. Oh, I have Python 3.11. And I also have, if I do conda list, a shorter list, simply because this is all of the libraries that are required for a tool and not everything else. But how is this important for reproducibility? Well, I can actually ask Conda to export this environment with Conda export. I believe that's the command, and I can call it dpl py4.json. Excuse me a second. I simply forgot. Ah, I was right. Almost. Conda env export. And I will need to redirect this to dpl py4.yml and not JSON. Let's see if that works. Yeah, I do get the same warning as before, but please do ignore it. And if I were to cat dpl py4.yaml, here I have an entire list with the versions for each installed software in the format of a YAML file. And what this means is that I can take this YAML file, bring it to my collaborator and tell my collaborator, hey, collaborator, please do conda install this specific YAML file, and that will ensure that that specific tool will run on my collaborator's computer. So going back to learning how to work on the cloud, I strongly do suggest looking into working with software environments and environment managers. I am pushing to use Conda simply because I find Conda to be extremely useful and easy to learn. And also because it comes with an extensive amount of support across the open science community. It is installable on all software environments, on all operating systems, and therefore makes this extremely flexible when it comes to trying to replicate someone else's environment. Lastly, I do need to mention that Conda comes in a couple of flavors. Mini Conda, which is just the Conda engine and a couple of modules, and Anaconda, which is everything that Mini Conda comes from, plus 150 modules and a user interface for folks that aren't as familiar with using the command line. And therefore, Conda is extremely powerful. I will suggest to install it on your computer for reproducibility reason and also for allowing your tools not to clash for dependencies. I did talk a little bit about containers last time around as well. And containers are an extremely powerful tool. And I remember one of the questions that somebody asked me was, well, if containers take all of the software and all of its dependencies and put them in a single container, and you will not need to run a VM and whatnot, what's the difference between a software management tool and a container? Simply speaking, the container and the software manager, in my view, they're used in different moments during a development range. The Conda can be used early on when you're trying to figure out what tool you require for your pipeline and what dependencies the tool requires. And then the container can come later down the line where you are closer to finishing up your studies or you're finishing up your project and you decide to take all of these tools and dependencies and pack them into a single container. This container this technology allows us to make software extremely mobile or mobile, allowing you to run things that are developed on Linux or an ARM Mac and have them run on, for example, a Windows computer or a different Ubuntu computer. And that's what container technology is. It takes all of the dependencies and tools that you require for a pipeline or a specific project and packs them up into a single container. Containers can then be uploaded to a registry or a hub, in this specific case, the Docker hub, and can be pulled from collaborators or other folks around the world in order to run on their own computers. Okay, I needed to run through these quickly simply because we are talking a little bit about reproducibility. Before I continue, I do want to ask if there are any questions regarding containers or software environments. And I'm going to give folks roughly 10 seconds to ask anything. And if not, I'm going to move on JetStream2, to JetStream2. Okay, your 10 seconds are over. I'm moving on. I've added here notes on the HPC and why working outside your machine is important. I am not going to run on the HPC unless we have time today. I have added a bunch of notes that will hopefully cover everything that you require to just get you started on the University of Arizona HPC. So with that, I am going to scroll down very quickly because this is a lot of information. And now we get to talk a little bit about JetStream2. So for the folks here in the room, what is JetStream2? No idea.
After JetStream1.
After JetStream1. No idea. Okay, so what is JetStream1?
It was JetStream1. That was an NSF project.
It was an NSF project.
Yes, cloud computing.
Okay. Yes, so let's talk a little bit about. Oh, Tanish says a supercomputing platform. Yes, Tanish, it is a supercomputing platform, give or take. And let me explain a little bit about what is going on and how did this came to fruition. For this, I'm going to, I think this pauses my screen sharing. Yes, it does pause my screen sharing, but I do not just want to pause. I want to stop sharing for a second. Okay, so this company, not this company, this organization right here, Cybers, had an idea a long time ago. And the idea was allow for folks around the world, not only in the United States, to have access to virtual machines. And virtual machines of any size became the lifeblood of Cybers for a really long time. Cybers is known to allow you to run your own containerized tools, but at the time, it would also allow you to have your own virtual machines to do any sort of computing that you may require. But now, it just became larger and bigger than Cybers could hold, and therefore a proposal was sent to, I believe, was the NSF to allow for this virtual machine project to become larger and more than just Cybers. So JetStream was born. And by the way, this project was called Atmosphere first. And then I'm not sure how it became JetStream. For folks that are in the physics, I'm sure you might know what a JetStream is, but we're not going to focus on that. So JetStream grew out of the basics, not the basics, but the beginnings of Atmosphere. And it found a home between Indiana University and TAC, the Texas Advanced Computing Center. Cybers always had a connection to JetStream and JetStream2, and a lot of our development is actually very closely related to the folks at JetStream, Indiana University, and TAC. So the idea is still the same. Allow for researchers to access virtual machines and do the research that they require. So enough of the history lesson. Let's look a little bit about what JetStream looks like today and how you can get access to it. I'm going to show you a little bit of something called Exosphere, which is one of the ways you can get access to allocations. And what you're seeing right here is a little bit of a convoluted page. You can access this by going to jetstream.exosphere.app. And what you're seeing on the screen is the free graphs regarding how much root disk you've used, how much RAM you're using, and how much CPU and GPU power that I have been using since this machine has been running. As you're noticing, this is both CPU and GPU. And if I remember correctly, they have H100s. Let me check very, very quickly. A100s, not H100s. Excuse me about that. And as you can see, nothing is happening right now. I've only created a very small machine for visual purposes. If I were to scroll down, it tells me that one, I can connect through native SSH, and I have a small passphrase that I can use in order to connect to this machine. So I could go open up my shell and connect, but what if I don't want to do that? Well, one, I have a web shell. So if I click on the web shell, I'm gonna connect to something called a Guacamole server, and I now have a functional working command line here online, essentially. I can go ahead and type pwd, who am I? I can also go ahead and look at NVIDIA SMI. And I can see that, well, there is a GPU that I am attached to. I can see that, yep, it is an A100X8C. So I am connected to a machine with a lot of power behind it. I do not have much. This has basic softwares installed to it. It does not have Conda installed, but it does have Docker installed. And what that allows you to do is that you can go to, for example, pub.docker.com, and maybe we can look at Olama, and maybe we can even, let's see if we can make this work. Maybe we can even do a Docker pull command, go back to our machine, and I'm gonna paste it. I can't see because Zoom is in the way. I'm gonna press enter, and I'm now downloading Olama. And for the people that don't know what Olama is an LLM developed by Meta. If you do want to do this, we can probably try to do this at the end. I'm just showing you how it is going on. You look like you have a question of sorts. No, okay, cool.
It's for running local models, right? It's not an LLM itself.
It's for running local models, yes. You can use, no, yes, it is for running local models, yes. I am very well, I will take your feedback, and if I say something wrong, do yell at me. Okay, cool. If Olama is a Docker for running LLMs?
analogous to Docker controls.
I think that's a bit far-fetched. But it's not a bad idea. I mean, I can see where you're getting at here. Are we covering Olama in LLP? Oh, sorry, we're covering Olama in LLP-ish, right? Yeah.
Yeah. Use it.
Yes, and well, if you do want to know more about Olama, I suggest you partake to the Gen AI workshop series that we also have going on. They know a lot more than what I know.
Beautiful.
It is,
It's not a Docker because it's an executable. You run it interactive.
You-
It's not
yeah, you download it, you
executable.
you tell it to essentially download a model with it, and then you can go ahead and run a small LLM with it. I digress.
Keeping the-
That is a-
No, that's fair. Thank you. Thank you for asking questions. But what I wanted to show you with this, coming back from our small little discussion, is that this is a virtual machine able to download Docker containers. This is a machine that's able to connect to, excuse me a second, to connect to the to a very powerful GPU. And it is not only in black and white and on a terminal. You can actually going back to Exosphere, open up your own web desktop. And right here, this will function like your virtual machine from very far away. I can go ahead and open up a terminal, and here I could go ahead and let's see Docker images. Yeah, it looks like it has downloaded Olama, and ideally I could go ahead and do my own work on here. But before I want to do that, I don't know if we have time to do that. I want to show you how to get here. And for that, I'm going to go back to my notes and talk a little bit about what Zoom is in the way again, what JetStream2, how to get access to JetStream2, and what JetStream2 runs on. Tanishka did give us an insight into what it may be. He says it's a supercomputing platform. Well, yes and no. This is a cloud computing environment which runs on the OpenStack network, meaning that it is like a supercomputer, but it is the machinery behind it, it is not built to be a supercomputer. Instead, these are computers that are quote unquote independent to one another, but are made to connect. So a bunch of these computers are at Indiana University, and another part of these computers are at TAC. Recently, Cyverse has purchased a number of computers in order to add to the OpenStack network and have JetStream running on it. It allows you to select a number of virtual machine sizes with specific requirements, including GPUs, as we have seen. The only drawback is that these root disks have a max of roughly 60 gigabytes, but this is something that we can that we don't have to worry about because we can attach a volume that can go up to terabytes of space given your the amount of allocations you have available. Now, All right, so JetStream2 is the car, right? Let's go with this analogy. JetStream2 is the car. It has everything you have. This is where I tend to lose people because a car cannot run without the keys. And the keys in this specific sense is something called access. And access is, I'm gonna use the word access both to talk about accessing and also to talk about access the allocation counter. So keep that in mind. JetStream is the car. Access is the keys. And access is funded by the NSF. And let me send this into the chat. And what access allows you to do once you have set up your account is to select how many allocations you want for the use of JetStream2. So essentially, you are selecting what car you want. You are selecting the keys for a specific car. Going back to my notes, because I'm gonna lose people in just a second here. Access, formerly known as Exceed, comes with different tiers. And I want to first say that anyone in academia or adjacent to academia can get allocations from Access. But this does change, or the amount of allocations does change depending on how many allocations you require. And through that, you will need to change the length of your proposal. There is I would say 3+1 different proposals. The first one is the Explorer tier, which gives you a pretty good amount of allocations. 400,000 allocations is enough for a small to medium size research. And it is great for evaluating further resources. And honestly, it requires just a paragraph of your own time. You literally have to go there and write, not go there, excuse me, go to Access and submit a paragraph long explaining what your research is about and what you're going to do with these allocations. And it only becomes a little bit more difficult from here. For 1,500 allocations, the Discover tier, which is really good for modest to larger research, requires, quote unquote, only a page long. And this is about who you are, who you're going to collaborate with, what your role is going to be. And then you can, the next tier after that is the Accelerate tier, which is for mid-size to larger scale researches. And this gives you the double the amount of what Discover gives you, which is full of 3 million. I think I said 1,500,000 earlier wrong, but I mean 3 million this time around, and it does require 3 pages long and more information on what the research is about. In order for you to get the maximum amount of resources, it requires a much more larger proposal, up to 10 pages, and it will be up to you to ask how many allocations you want. Therefore, that's why I say it's a 3+1, where you have Explore, Discover, Accelerate, and if you really know what you're doing, you can go for Maximize. Now, Access is great because you do not, or Access and JetStream are great because you do not require the permission of a professor to literally gain access to JetStream and do your research. You could be a graduate student requiring to do some research, but you don't have access to the HPC, for example, and therefore you can apply with a paragraph long and hardly I don't know anybody that has ever been refused a an access allocation. So you can start with a small little explore and try to do as much as you can. It does not mean that if you start with explore, you cannot go to discover. Actually, that's what a lot of people do. You start with explore, you run a bunch of allocations or run a bunch of analysis, you discover that you require the next step, and therefore people go for discover. The process itself, I will have to log in. I'm going to do that real quick. It will require you to do authenticate. Do authenticate. All right, so now you're in. Once you are logged in, you can go to the top left side allocations, where you're gonna see a small little yellow button that says request new project. Once you click on that, you can go ahead and request an explore access point. You will have to go through your information. Ooh, I should update that. Now everybody knows my work phone number. But here is where you fill in everything that you require. And where is the button? Save profile. Why can't I? Oh, it's because Zoom is on it. Okay, save profile. And now you can go ahead and type in or put in your document, ask what resources you want in the specific case you want access credit, and you will click submit. This is all you have to do. Put in a single document, save your personal information, select your available resources, and click submit. It's quite straightforward. If you are applying for something larger than an Explorer, you will have to select who else is working on it, and that's not a problem. You might want to also write down other collaborators or select different supporting grants. All that Access and JetStream ask of you is that you cite them once a publication is made. But let's assume you just applied and all of a sudden your allocations are approved. What it will look like is something like this. You have a number of projects. In this specific case, I have 3 active projects that I'm on and 2 inactive ones. And you will be given a stack of credits that you can exchange. I am gonna go ahead and open up this post-simulation computational resources for a molecular dynamics simulation repository. And as you can see here, I have roughly 320,000 access credits available, and I can click on exchange credits for resources. Can I click on it? Oh, they changed it. Ah, it's over here, credits plus resources. And here I can see the breakdown of the credits that I have allotted for the specific projects. Over here, I can select, or I ideally could change this to something that I wanted. But as you can see, I have put resources towards CPU, GPU, and storage. But recapping what I'm trying to show you here, we are trying to go from the keys to actually using the car. You will have to go through Access in order to use, so you have to log in into Access, sign up and log in into Access, select an allocation amount that you want to between 400,000, 1,500,000, and 3 million. and set in your proposal. And then within between a few hours to maybe for the larger projects, maybe a few days, you will get your access accounts, where then you're gonna not accounts, access credits, where then you're going to exchange your credits for allocations. And once you have your allocations, you can go ahead and start using your virtual machines. For example, here, I have said that you can use CPUs, GPUs, storage, and large memory. There is a reason for everything, but I do need you to understand that GPUs will burn double the amount of allocations as CPUs. Each of these types of virtual machines come in different flavors. And if you want to use a CPU flavor, for example, they start from very tiny or M3 tiny, 1 CPU to 2XL, which is 64 CPUs and 250 gigabytes of RAM. There is a breakdown of how many allocations they're gonna burn per hour. I will say for anything and everything, just stick to the M3 medium if you don't know and if you're just starting. That is 30 gigs of RAM and 8 CPUs. You can get quite far with that. If you want to use GPU flavors, these are NVIDIA A100s, and unless you do ask for a G3 XL, you will receive percentages of these GPUs. So for example, if you ask for a G3 small, you're going to get only 20% of the GPU, which is roughly 8 gigabytes of that GPU, which is not bad. Just know that there may be other people using the same amount of the GPU. Or you could go, if you already know what you want and you require 20 gigabytes of RAM, you can go for a G3 large, and just know that this will cost 32 SU or allocations per hour. Then there is large memory flavors, which I haven't really used, but these are quite expensive. However, if you know what you need this for and you need 1 terabyte of RAM for your research, go ahead and use it. I did talk about SUs allocations, but a lot of the times the question comes down to, okay, how much do I know? How do I know how much it's going to cost? Well, you can use the JetStream2 estimator calculator. And this is exactly what it is. You know, this is a calculator for how to find out what tool or what VM you require. So let's see. I know that I want a G3 medium, and it's going to be active for 24 hours a day because I'm running a model. I want a single instance and I want it to run for 3 days. And I know that I'm going to burn 1,152 SUs, which if I were to look back at the nodes, it's only a fraction, an absolute small fraction of that explore tier. And all you need to do is to submit a paragraph long explanation of what you need to do. With that in mind, do have a plan. Do understand what you want to do before you start. Do you have a plan on how to transfer files, how to download these files? So by all means, that paragraph long shall mention what you want to say, as in what your plan is, as in, I think I need to run, not I think, I will need to run my model for roughly 3 weeks, which I assume it's going to cost X many units, and therefore have a plan before applying to Access. But let's assume that you have applied and Access gave you access to JetStream2. how do I get to now use JetStream2? There is 3 ways for using the JetStream2 machines, and these are Exosphere, Horizon, the command line interface. There's another one also called Cacao that is not written here. I'm gonna scroll down because it's probably easier to show you and to actually explain to you how to do this, how to get to a machine. First of all, Exosphere is the easiest. It's user-friendly. There's a nice interface that you can access without issues. Horizon is the most difficult to use, but if you know what you're doing, I strongly suggest you use Horizon. And then you have Cacao, which allows you for deploying multiple VMs, Jupyter Labs. I've used Cacao in the past for running multiple workshops, so it depends on what you want to do. And for this specific case, we're going to go look at Exosphere. I already have sent Exosphere into the chat, but I'm going to copy this again and put it into the chat once again. Do ignore these errors because they are dangling and will not affect you. So JetStream2, let's assume that this is my first time and I have nothing here. What I will need to do in order to connect access to JetStream2 is to click on this Add Access Account. And here I will then click Add Access Account. I'm not going to go ahead and do it because this is going to make JetStream2, this is going to make Exosphere break. But you're going to click on Add Access Account. You're going to log in, and within a few seconds to a couple of minutes, you're going to see something similar to what you're seeing here. And these are your allocation numbers, and your allocation numbers are the same as the ones that you see in your project. So if you're lost, just know that, for example, TRA 220028 will show up here as your allocation number. What you want to do now is that you want to click on your allocation. And as you can see, I do have a number of instances running already. And let's say that I want to create another instance. I will go ahead and click on create on the top right. And I want to create an instance in this specific, on this page now. I can either go by type or by image. And let's move this around. By image is all the virtual machine images that are either supported by JetStream2 or an image that you have uploaded yourself. Look how many there are over here. But let's just go by type. And I'm gonna look to create a virtual machine with Ubuntu 24. I'm gonna give it a random name because I really like their names. Likely Steered Monster. And let's say that I want to run an M3 medium. This is honestly going to be this is my favorite because it has all that I require without a GPU. For some reason, it's the visual of this is breaking, but don't worry, we can still use everything that we want. As you can see over here, it does say that the root disk is 60 gigabytes full stop. However, we can go down here and customize the disk. Let's say that I want 100 gigabytes root disk. And I can even create multiple of these if I wanted. I'm just going to create one. I do want to enable the web desktop, and I can even add an SSH key. I'm not going to add an SSH key right now. And if you don't ask for an SSH key, it is going to give you a key that you can use to launch or connect to this machine. It's really difficult to see right now, but advanced option, hide or show. But I think I'm done. I'm going to create a medium general purpose virtual machine. with 100 gigabytes of space, a web desktop, and I'm not attaching an SSH. I'm gonna go ahead to move this around and click create. So what this is going to do, it is going to start building this virtual machine and adding a volume for it. I was running a small little test earlier and I created 2, 3, 4. I created 10 different or 10 GPU backed machines. I had planned to put this into a Google Doc and share them with you, but maybe we're gonna do this the next time around. I'm gonna click on this, and whilst this is building, I would like to show you steps that you might want to do after you build your machine. So let's assume that yes, you have created 10 different machines. Now, what can I do apart from going to the web desktop, do whatever that I need to do? I can turn them off. What if I don't want to turn them off, but just put them onto the side? I will have to go to actions, and here I can choose to lock shelf, create a snapshot of this image, and this is of this instance, sorry, and this is the image factor that we were talking about earlier. We can restart the machine or we can delete it. Now, lock will allow for you not to make any changes to the machine at the moment. Shelf will just not power it down, I'll put it on standby. But in this specific case, we want to delete it. So we're gonna go ahead and click delete. Are you sure you want to delete? Yes. And it's going to delete one of the machines that I have created earlier. I can also go ahead and destroy multiple machines at the same time. I should have thought about this beforehand. And I can go ahead and delete 9 different machines at the same time. And as you can see, my machine is still building. It started 2 minutes ago. Hopefully it won't be too long. And whilst that's building, what else can we talk about? I can talk to you about where to find documentation. I'm gonna copy and paste this into the chat because usually folks always come and ask about one thing, which is where can I find more documentation? Well, the official JetStream2 documentation goes very well in depth on everything that you can do in JetStream2. I'm not gonna go into too much details here, but this is your JetStream2 home. Access portal is once again where you can figure out where to get your keys, essentially. And then I've added the Exosphere portal, the Horizon portal, and the Cacao portal in case you want to use or want to try JetStream2 in your own time. Let's see if it's done building. It's still building. Oh gosh, I'm gonna reload this. Do ignore the errors. Why can't I? Oh, it's because the chat is open. Okay. Well, now we know that it does take roughly 4 minutes to create a machine. Now it is running a setup. It won't be too long until a machine is ready. But other than that, really, I think this is a good time to chat about if you have any questions regarding what JetStream2 is, how to run things on it, if there is any limitations. I know that folks sometimes are not happy with just 40 gigabytes of a GPU. So one of the questions sometimes is, can I connect two virtual machines for a total of 80 gigabytes? Yes and no. This is still in the quote unquote beta phase. They're still working on allowing different GPUs to talk to each other, but it is something that they're working on. So perhaps this is something to look out into the future. Another question that has popped up in the past is, would I be able, how difficult is it to renew your allocations? Actually, renewing your allocations is pretty darn simple. You will receive an email saying, hey, your allocations are running low. And there is a little link that you can press to extend your allocations. These allocations run every year. So if you're not running out of allocations, you can just extend them, and they will give you more time to run your analysis. Now my machine is ready. I can go ahead and click my my web desktop, because I can. And here I have my web desktop ready to go. I can still install Llama, but if I do NVIDIA SMI right now, it does not have the NVIDIA driver running at the moment, but bless you. If I were to do LSB release, it does not have LSB released installed, but however, my point being, this is a functional virtual machine with Ubuntu running, and no, they do not have Windows servers. They do have Red Hat-like servers, but I believe this is all I have for you today. I created a small machine. I'm going to delete it. And it took me, what, 5-6 minutes to get a machine running. Pluses for using this system, it doesn't get bogged down as much as the HPC does. So by all means, I will suggest getting to be comfortable with JetStream2. Is extremely powerful, is extremely useful. And therefore, with that, I wanted to close today with a thank you with for your patience and for your attention for today. And next week, I am planning to use JetStream2, and for anyone that wants to start walking through creating our pipeline or understanding the steps on creating our pipeline. So with that, thank you very much for your attention, and I hope to see you all next week.